Hi, I'm Elena and I'm part of Challenge 2016 here at Georgia Tech. For this video, I'm going to be explaining how to find the volume of a torus or a donut. So first of all, our donut in 2 dimensions is centered at r of 0 with our big R of 0, and we have a small radius r. So the endpoints are big R minus little r and r plus r. So to find this volume of integration, we first have to solve for, for x. And how we do that, or how we even think about how to start up the equation, is we start by doing x squared plus y squared equals r squared. This r is involved, so now it becomes x squared, x minus r squared plus y squared equals r squared. And that's how we get this equation. What we are going to do now is we're going to solve for x. Let me change the camera a little bit so we can see me. Square root of both sides, or first of all, we're going to move the y over here, so minus y squared. We take the square root of x minus r squared equals the square root of r squared minus y squared, and we get x minus big R squared equals plus or minus the square root of little r squared minus y squared. Now what we do with this plus or minus is we're going to break it up into these two parts, r plus square root of r squared minus y squared, and r minus the square root, I'll make sure I say little r from now on, little r squared minus y squared. And we're going to subtract these in our integration to solve for the volume. So we know that to solve for volume, volume is equal to pi r squared. So we say volume is equal to pi, the integration of negative r, which is here, negative r, to positive r, from big R minus the square root of little r squared minus y squared, and this is all squared, minus big R squared minus the square root of little r squared minus y squared, and that's all squared to the dy. Once we square both these terms, and this simplifies to equal pi, the integration from negative little r to little r equals 4 big R square root of little r squared minus y squared dy. And that's the same thing because we're going to take the 4 big R out in front of the integration sign, so we can just focus on the latter part. So this is equal to 4 big R pi, the integration of negative r to r, square root of little r squared minus y squared dy. Now we're going to take, you're like, oh my gosh, what are we going to do now? So from this part, I'm just going to focus on this integral, and we'll come back and multiply that in a moment. Let me make sure my camera's still. Okay, cool. So how do we get from here down to an actual equation? How are we going to integrate this first of all? So we draw our triangle, label it. X is our base, square root of r squared minus y squared is our height, and r is the hypotenuse. So we know that y is equal to r cosine, and that means dy is equal to negative r sine theta. So we can say that the square root of r squared minus y squared is equal to r sine. So what we're going to do from now what we're going to do is we're going to take the integral from 0 to pi, because those are the limits of a circle, r squared sine squared theta d theta. Again, we're going to take this term out, the r squared, so it becomes r squared evaluated from 0 to pi sine squared theta d theta. This identity is equal to 1 minus cosine 2 theta over 2. But what I did was I took the 2 from the denominator and just stuck it in front of the integration sign. So now what we're integrating is from little r squared over 2. We're evaluating from, we're taking the integral from 0 to pi, 1 minus cosine 2 theta d theta. And when we take the integral of that, we get r squared over 2, and we're going to evaluate that, theta minus sine of 2 theta, and we'll evaluate that from pi and 0. So for everywhere we see a theta, we're going to replace it with either pi or 0. R squared over 2, and this is outside the parentheses, pi minus sine of 2 pi minus 0 minus sine of 0. Sine of 0 is equal to 0. Sine of 2 pi is equal to 0. 0 equal to 0. So now we get that little r squared over 2 times pi. And we just proved the area of a circle. Area equals 1/2 pi r squared. Now, as we said before, we go back to where we solved up here. We're going to multiply it by 4 big R pi times the area of a circle, and that is equal to 2 big R pi squared little r squared. And that is the volume of a torus or donut.